Ever wondered why plants are so essential to our daily life, beyond just oxygen and food? Plants, the green warriors of the earth, are much more than they seem. They contain a secret world of chemicals, specifically referred to as phytochemicals. These are powerful compounds that the plant kingdom creates as a part of their survival strategy. But their importance extends beyond the confines of the plant world. These phytochemicals, which include substances strychnine, atropine, and reserpine among numerous others, are of incredible value within the domain of pharmacology. They lay the foundation for several medicines, acting as the crucial elements in their composition. These compounds have capacity to combat a broad spectrum of human health issues, from common colds to life-threatening diseases. Hence, plants not only give us oxygen and food, but also the key to healing and health through these phytochemicals. So let's dive in and explore these amazing natural compounds. Beginning our exploration is strychnine, a potent compound originating from the Strychnos nux vomica tree. Indigenous to India and Southeast Asia, this leaf-shedding tree is recognized as the primary source for strychnine. The compound is predominantly found nestled in the plant's seeds, characterized by its acrid taste and highly poisonous properties. Delving into a more detailed exploration, strychnine is a forceful neurotoxin that directly impacts the central nervous system. It's notorious for its role in initiating seizures, owing to the disturbance it causes in motor neuron control. The process of isolating strychnine is a detailed one, requiring extreme precision. The use of solvent extraction, utilizing a concoction of dichloromethane and methanol. This procedure differentiates the strychnine from the other alkaloids present in the seeds. To establish the presence of strychnine, several specific tests are executed. One such is the Myers test, which results in a cream precipitate, thereby confirming the presence of this powerful compound. Strychnine's potential as a neurotoxin is a stark reminder of nature's duality, harboring both healing remedies and lethal poisons. Strychnine, a potent neurotoxin, indeed proves that nature holds both cure and poison in its hands. Next on our list is atropine, a compound with a long history in medicine. It originates from the deadly nightshade plant, Atropa belladonna, and is a potent tropane alkaloid with diverse therapeutic uses. Intriguingly, atropine is an anti-muscarinic substance, meaning it counteracts acetylcholine, a neurotransmitter, within the central and peripheral nervous system. This interaction can lead to various effects, such as an accelerated heart rate and decreased salivation and perspiration. The extraction of atropine involves separating it from the plant through solvents, followed by thorough purification. This procedure, however, is best left to experts due to the compound's potential toxicity. The identification of atropine can be achieved through several tests. High-performance liquid chromatography and mass spectrometry are commonly employed for this purpose. These techniques facilitate accurate detection and measurement, enabling safe and effective usage in medical practices. Atropine, a fascinating compound, showcases the immense pharmaceutical potential of plants. Moving on to reserpine, a compound with a calming effect. Reserpine originates from the dried root of Rauwolfia serpentina, a plant from South Asia. This compound is captivating as it has a natural ability to regulate neurotransmitters in the brain, essentially behaving like a tranquilizer. The process of its isolation involves a meticulous extraction from the plant's dried roots. These are treated with a solvent, often an alcohol, which dissolves the reserpine. The solvent is then evaporated, leaving behind the reserpine as a crystalline solid. To confirm the presence of reserpine in the residue, tests are carried out. These tests focus on its characteristic effects on the central nervous system. The tests are typically conducted on lab animals and involve observing changes in vitals like blood pressure and heart rate. These changes confirm the presence of reserpine. This compound, a natural tranquilizer, is a testament to the varied impacts phytochemicals can have on our physiology. These impacts can be diverse, ranging from modulating neurotransmitters to affecting vital signs. In the realm of phytochemicals, reserpine stands out due to its tranquilizing properties. Our exploration of phytochemicals does not end here. Stay tuned as we delve into more of these fascinating compounds in our next segment. Ever wondered what gives black pepper its pungent flavor? Meet piperine, a fascinating fiery compound that's born from the Piper nigrum plant, which you and I fondly know as black pepper. You can find it tucked away in the pepper's outer layer, standing as the true epicenter of the spice's renowned bite. Diving a bit deeper, piperine is a crystalline alkaloid carrying a molecular formula of C17H19NO3. It might sound like complex chemistry, but its role is remarkably simple and powerful. Apart from its notorious heat that adds flavor to your dishes, piperine plays a crucial part in your body's wellness journey. It's documented globally for its role of enhancing the absorption of other nutrients like curcumin, working tirelessly behind the scenes to optimize your health. You might be wondering, how do we manage to extract this powerful, punchy compound? The answer lies in a scientific process known as solvent extraction. We use a suitable solvent such as ethanol, which dissolves the pepper effectively. Following this, we evaporate the solution, inviting the remaining piperine to take center stage. Confirming its presence is a fascinating process in itself. There are several tests that can be performed, ranging from melting point determination to thin layer chromatography. These tests identify the distinct characteristics of piperine, securing its identity. This proves that the fiery piperine isn't just a myth, but a reality, working wonders in your everyday dishes. Piperine, a compound that adds more than just flavor to our food. Next, we have a trio of phytochemicals: Taxol, Sennosides, and Digoxin. Let's dive in. Taxol, a complex diterpene, is derived from the bark of the Pacific yew tree. This remarkable compound has the unique property of stabilizing microtubules, essentially freezing them in place. In the context of cancer cells, this prevents cell division, making Taxol a potent chemotherapy agent. To isolate Taxol, the bark is soaked in a solvent like methanol, allowing the phytochemical to be extracted. The presence of Taxol can be confirmed using chromatographic techniques like high-performance liquid chromatography. Moving on to Sennosides, these are derived from the senna plant. They are glycosides, meaning they are sugars bonded to a non-sugar compound. In this case, that non-sugar compound gives Sennosides their potent laxative effect. To isolate them, the leaves and pods of the senna plant are subjected to a process called maceration, essentially steeping the plant material to extract the desired compounds. The presence of Sennosides can be confirmed using thin layer chromatography. Last but certainly not least, we have Digoxin. This cardiac glycoside is derived from the leaves of the foxglove plant, Digitalis lanata. Digoxin has a unique property of slowing and strengthening the heart rate, making it a valuable treatment for heart conditions like atrial fibrillation. The isolation of digoxin involves drying and powdering the leaves, followed by extraction with a mixture of chloroform and methanol. The presence of digoxin can be confirmed using a color reaction test with Keller-Kiliani reagent, which turns a distinctive blue-green color in its presence. These three phytochemicals demonstrate the incredible range of medicinal properties that plants can offer. From fighting cancer cells to regulating heart function, these phytochemicals are true lifesavers. Phytochemicals, nature's own pharmacy, hold immense potential in shaping our health and well-being. We've journeyed through the intricacies of strychnine, atropine, reserpine, and piperine, each with their unique properties and methods of extraction. We've also explored the multifaceted nature of Taxol, Sennosides, and Digoxin, delving into their isolation and tests. As we unravel the secrets of these natural compounds, we realize how intertwined our lives are with the plant world. Subscribe for more because you won't find me later.